Now, it is not what we teach, it is basically what you learn. It has come all the way from teacher-centric education system to the student-centric education system. Earlier, we were talking about the objectives of the course, and in today's context, when the whole world is going on outcome-based education, we talk about outcome restriction. It is not student-centric anymore. It is not learning objectives anymore. As a matter of fact, it is learning outcomes. Now, this is a simple framework of outcome-based education. The entire scenario of OB is bundled in this particular framework. We have at the first initial stage the course planning and delivering in terms of syllabus, teaching methodologies, various forms of assessments. The assessment is done at different levels, at the course level, at the program level. And then when it comes to the outcome, what are the things that we measure actually? We measure certain parameters. One is the course learning outcomes. Every individual course that is actually taught in the 4 years of undergraduate here in our country, we measure the outcomes for all the courses, and then we measure the program outcomes once the student gets graduated. Then we have program educational objectives. And then finally, we land up measuring the vision and mission of two stakeholders. One, we measure the vision and mission of the department itself. And then down the line, we measure the vision and mission of the institute. Now, this is the typical process involved in teaching learning that we adopt in our institute here. The steps involved are basically into 5. We have the subject allotment that takes place depending upon the expertise of the faculty members. The subjects are allotted. There is going to be a pre-commencement meeting where the faculties, 2-3 faculty members who are handling the same subject, they basically come together, discuss about various methodologies to be followed, various assessment pattern to be done during the course of the semester. And then we come to a common conclusion in terms of the preparation of the lesson plan. That is actually which gives us the flow of the course throughout the semester. Typically, a course here is approximately 48 to 50 hours. We also chalk down the different forms of assessments, and then the outcome is nothing but the attainment. Just a quick glance about Bloom's taxonomy. As you're all aware that it has been translated into 22 languages, and Bloom's taxonomy is one of the most widely applied and often cited references in the field of education. And there is a transition in this Bloom's taxonomy. Originally, it was in the form of noun, which came way back in 1956. And there are 6 levels of Bloom's taxonomy, which was further in 2001 was revised, and it was called as Anderson's Crothwell revised Bloom's taxonomy. The only small change in the taxonomy level was the first 4 levels were same, but the 5th level, that is synthesis, which was there in original taxonomy, now moves up to the 6th position. And now in the verb form, it is called as create. And the evaluation, which was there in original taxonomy, has slightly come down to the 5th position. Of course, the cognitive level still remains the same, that is evaluate, and the transition is from noun to the verb form. The beauty of this taxonomy is the first 3 taxonomy levels, that is remember, understand, and apply. We usually term it as lower order taxonomy, and the remaining 3, that is analyze, evaluate, and create, we call it as higher order taxonomy levels. This is how we follow here. The first 4 taxonomy levels, as of now, we are evaluating, keeping the fixed hour examination in mind. That is a combination of 2 parameters. The first one is called as continuous internal evaluation, and the second one is called as semester end examination. So by and large, the courses which comes under the category of professional courses, it can be professional electives, it can be open electives as well. These are all the courses that we measure, in fixed hour examinations. On the contrary, the 4th, 5th, and 6th level of taxonomy, we measure in terms of mini projects and major projects. Every student undergoes 1 or 2 mini projects by the end of 3rd year. And during the final year of the graduation, they work on the major project, which is actually split into 2 semesters. These are the different aspects of taxonomy level. What are the verb forms that we can use actually? Let me come to the course outcome and program outcome, the crux of my discussion. The course that we teach, we have to come out with the course outcome, which is also called as learning outcome. As you all know, course outcomes are nothing but what the student should be able to do at the end of the course. As I told you in the beginning that today's context is not learning objectives, it is learning outcomes. So what will student learn today? And that is what we do the moment we enter the class, the teaching is class, or probably at the end of today's session, you will have outcome-based education. Now, when we are drafting the course outcomes, we land up drafting a couple of course outcomes. The course outcomes should be specific, measurable, achievable, relevant, and time-bound. If we do not follow these, simple steps of the course outcomes, then the assessment somehow will land up taking place. But I doubt whether attainment will really happen actually. So we have to be extremely careful as a teacher that when we are drafting the course outcomes, we should keep all these things in mind from the student's point of view. So basically, the course outcome should be written for the student using the action verb, which belongs to different cognitive levels. The process that we follow at the computer science department here to maintain the quality of course outcome is when the 3 teachers or 4 teachers who handle the same subject sit for the discussion. As I told you earlier, that is pre-commencement meeting. We basically pull in thoughts, we pull in our experience in handling that particular course. We refer some sort of literature survey, previous years university question papers and other institutes, other universities, top level universities. And then we draft the course outcomes, keeping in mind the revised Bloom's taxonomy along with the noun verbs. And then we get it verified with the senior most faculty, because sometimes what happens is, let us say, for example, there are 3 faculty members who are handling the subject. And there is also 1 or 2 more senior professors in the department who are well versed with that subject. Maybe they are not handling that subject this particular semester. So what we do is we get the, take the expertise of those faculty members, get verified the course outcomes that we have drafted. And finally, we will send it to the program coordinator or head of the department for the final approval. Now, when we draft these course outcomes, we also draft the assessment pattern. And at the same time, we will also fix up the target. Now, why is this target required? The target is required to ensure that the attainment is done in a very, very proper way. Because as a teacher, I would always like to fix the target and try to put whether they are in a position to achieve the target or not. Now, the checklist for preparing the course outcomes is we always limit our course outcomes to 4 to 6. As such, there's no literature, as far as I know, written anywhere that the number of course outcomes should be so much. But then I always feel, based on my experience and my discussion with knowledgeable people like you, I have always drafted number of course outcomes as 4 to 6. And minimum taxonomy level is 3, because most of the courses, can be assessed using the first 3 taxonomy levels. But the course outcomes should be, drafted in such a way that it covers the entire syllabus. It covers the entire curriculum. In the sense, any query that I ask towards assessment to student, it should actually map to one or the other course outcome. And we also land up mapping the course outcome with program outcome, that is called as correlation matrix of COPO with proper justification. Now, program outcomes, they are narrower statements that describe what students are expected to know, and they will be able to do it by the time of graduation. Program outcomes are expected to be aligned closely with graduate attribute guidelines for the program outcomes. These are the graduate attributes. These are 12 graduate attributes. Starts all the way from engineering knowledge and goes up to lifelong learning. The first 5 graduate attributes, they are basically belonging to the technical aspects. And most of the courses that that we teach belongs to the first 5 program outcomes. The course outcomes can easily map to these 5 program outcomes. But at the same time, when we talk about the projects, that is mini project, major project, or seminars, or stuffs like other courses like management and entrepreneurship, they'll end up getting mapped even to higher program outcomes or graduate attributes. Maybe, for example, the project work can always go for program outcome number 9 and 10, where we measure the contribution of students individually and how he performs in the team. And when he lands up giving the presentation on the project work that he or she has done, we also land up measuring the communication skills of that particular student. The first 5 program outcomes, as I told you, they are purely technical theory courses between Bloom's level 1 to 4. Programmers them to apply a particular concepts are from 1 to 5. As I told you, mini project and major project, we also call it as main project. It can go up to the last level of taxonomy, that is cognitive level 6. Coming to assessment and attainment, as I told you, assessment and evaluation plays a vital role in outcome-based education. Effective assessment methods would be helpful in improving the student learning. Assessment is a systematic collection and analysis of information to improve the student learning. As a matter of fact, in OB, assessment is one or more process which is carried out by the department, by the institution. As a matter of fact, it's carried out by professors to prepare data to evaluate the achievement of 3 things. And those 3 things are course outcomes, program outcomes, and program educational objectives. Now, this is the place where we assess the different outcomes. Course outcomes are assessed at the end of the course completion. Say, for example, you have typical 5 to 6 courses in a particular semester. At the end of the semester, we'll end up assessing every individual student's performance with respect to every individual course. It happens for various courses spread over 8 semesters, because engineering year is of 4 years curriculum. And then at the end of 4 years, we'll end up calculating or assessing the program outcomes of the student. And
yeah, Professor, I am afraid, I think, you have to finish early. Okay. Can you finish in 2 minutes, please?
Sure. I'll skip this. I'll just give small stuff. This is a case study. We have this assessment pattern in our course, into assessment for 40 marks and end semester 100 marks. And this is what we do, the computation of course outcome, direct attainment and indirect attainment. Direct attainment, we get it through continuous internal evaluation and semester end examination. And indirect attainment, we get it through course exit survey. As the title of mine says, it's a case study. Let me give you the result of the case study and wind out. The final course outcome attainment, we do it 90% of the direct attainment and 10% of indirect attainment. Now, this is a case study of the graduate subject, which I handled last semester. It was titled Unix Programming. For all computer science professionals, you'll understand what exactly is Unix all about. The total strength of the class, in the sense not one class, it was spread over 3 classes through 3 sections, 213. We had set target of 60% for each of the course outcomes. So all the 6 course outcomes were having 60% as a target. We adopted different methodologies of assessment. We had 3 internal tests followed by assignment, quiz, and a small sort of mini project also. This is what I could assess at the end of the day, and this was the attainment. Incidentally, my course could achieve all the 6 course outcomes. As you see from the graph, it starts from 61.67 as a percentage of CO1, and the last course outcome was 67.07. This is the percentage of students achieving individual course outcomes. 57.75% of the students achieved course outcome 1. And as I told you that I had drafted 6 course outcomes, this particular graph tells you that 43.19% of the students in the course achieved all the 6 course outcomes. Incidentally, 11.74% of the students did not achieve any course outcome. Now, it is quite possible that a student would have got 59%. since my target set was 60%, even a guy who scores 59%, he will be coming under the category of no course outcome attained. So let me conclude. Course outcomes must be the target in all exams and assessment. Assessment that do not measure what course outcomes were are actually considered as poor quality assessments. Determining the strength is addressed and computing the attainment or approximation. Strive for continual improvement in attainment and demonstrate the improvements with evidence. Writing course outcomes and linking them to teaching and learning activities and to assessment, according to me, is a process and not an event that needs to be done only once. We have to continuously practice it and implement it and always go for continuous improvement. Remember, when we teach, we want our students to learn. Thank you, all of you. Thank you for your patience listening. Thank you very much.
Okay, thank you. Thank you for your nice presentation. And so we want to move to our next presentation. And I'm inviting Mr. Vincent N. Miklat, and he is a graduate of Bachelor of Science in Applied Mathematics from the University of the Philippines, Visayas in 2018. And currently, he is finishing his Masters of Education, and he is also an instructor at the Division of Physical Science and Mathematics. He has also experience as a senior high school mathematics teacher. So you can please, share your slides and start your presentation.
Can you see my slides already, sir?
Yeah, it's coming. I think we will be able to see. Yeah, it's clear now.
Thank you. So good day, everyone. I am Mr. Vincent N. Miklat, instructor from the University of the Philippines, Visayas, and currently a graduate student taking up Master of Education Mathematics from the same university. And in behalf of our group, I will be presenting to you our study, Anonyman, Accuracy of Encoded Mathematical Symbols in Elementary Algebra. So Anonyman is the Hiligaynon sentence that translates to what is this in English, seemingly representing learners' undiscovered confusions on mathematical symbols. For the background of our study was realized on three major thoughts. That is, mathematics is an abstract matter, mathematics is hierarchical in nature, and mathematics is highly symbolic in nature. So the concept of math is indeed abstract, and we often represent these concepts using real-world models. For instance, at the very young age, we are taught that the ball is a circle, and then later on, we will figure out that the ball is not just a circle, but actually a sphere, as we learn about solid figures. With that said, we can see that math is indeed hierarchical in nature as well. We need to learn specific prerequisites before we can understand the next, more complex concepts. It is also very obvious that we use a lot of symbols in mathematics, from the variables to the operators. Like variables to represent quantities. Then the relationships of these variables are established through the use of various operators and other notations. And from there, algebra revolves on its own. With the presence of these symbols, this implies the need to introduce, familiarize, and apply different symbols to understand higher algebraic concepts, such as mathematical modeling and problem solving, which is algebra's main real-world applications. We saw that failing to recognize these symbols can really affect learners' learning, especially as they proceed in higher learning mathematics. From there, we would like to take a look at how well our students encode these symbols through the seeing, hearing, and reading, or that is the SHR, which are the symbols or the modes of encoding and retrieval whenever we deal mathematical symbols. So for the framework of our study, so it is based on three existing knowledge. First one is the information processing model. So mathematical symbols that were processed in the sensory memory through the SHR, or that is the seeing, hearing, and reading, in the student's mathematical learning experience were the stimuli that underwent rehearsal in the short-term memory and encoded in the long-term memory. However, the learning experience the student had in this encoding of the mathematical symbols were a limitation to our study. The same processes of SHR will be used in the retrieval of the encoded information, which is our target, the accuracy of encoded mathematical symbols. Our second theory, or the second framework of our study, is from Ausable subsumption theory, which is more of a detailed version of the IPM, or the information processing model. So the same mathematical symbols will be accommodated in the visual register, heard ones in the auditory register, and then the read ones in both. In the working memory, seen mathematical symbols will be rehearsed in the visual spatial sketchpad. The heard ones will be in the phonological loop, while the read ones, of course, will be both. Encoded mathematical symbols in the long-term memory will be stored as a declarative knowledge. And that would be our target for, or if we're going to take a look with respect to subsumption theory. So the same processes of SHR will be used to retrieve our target, which is the accuracy of encoded mathematical symbols. Our last framework is from the VARC model, so which is the visual, auditory, reading, and kinesthetic model. But for this model, however, we omitted the kinesthetic encoding in the VARC model, as mathematical symbols were never represented through body actions. So instead, we incorporated feelings associated with the symbols. And the visual, auditory, reading, and feelings, or the VARF model, was used as the main process of stimulus acquisition and means of information retrieval. So the inclusion of feelings is based on the study on metacognition by Dr. Divina Gracia, is our advisor for this study. As she claimed that corresponding affective aspect is present in the entire process of problem solving, or as she named it, as the metacognitive knowledge of problem-solving emotions and attitudes. For our materials and methods, so for our exposure, our learners were exposed to different mathematical symbols through the seeing, hearing, and reading, or the SHR. And then we gathered the following data: the images seen, heard, or read, the manner it was read for reading, the corresponding name of the symbol and meaning associated with it, and the feelings felt after the exposure. And for the analysis, we have computed for the percentage accuracy of the seen, heard, and read symbols, and we performed thematic analysis for certain themes that we can extract from the numerical or quantitative data. And our main instrument to do the data gathering is our researcher-made questionnaire and scoring tool. So here is our method on how we constructed our questionnaire and scoring tool. So first, we identified the most common symbols in elementary algebra. Then we determined the fitness of these symbols on the three basic or three learning styles that we have mentioned a while ago, which is the visual, auditory, and reading. The 15 symbols are differentiated in 4 categories. So we have category A for symbols with one image and one meaning. Category B for one image and multiple meanings. Category C are symbols with multiple images but one meaning. And category D symbols are those with multiple images and multiple meanings. After that, we have comprehensively added all possible definitions to each symbol. Then these symbols were validated by the different mathematics teachers that serve as standard scoring for the tool. And the questionnaire and scoring tool were pilot tested in different schools, both private and public, in the Philippines. So here are the 15 commonly used mathematical symbols in elementary algebra as we have classified. So the meanings of the symbols that were exhaustively gathered and listed were based from what a grade 8 learner would know at that time or at that grade level. And here is how we differentiated the categories for the 15 mathematical symbols. So 8 symbols belong to category A, 2 symbols for category B, 2 symbols for category C, and we have identified 3 mathematical symbols for category D. Our participants are 35 learners from a highly selected institution in Iloilo City. Our participants are from a heterogeneous group of grade 8 students, of course, to address ethical concerns. So we have sent appropriate permit letter to conduct study to the principal of the institution, and we have distributed and gathered letters of voluntary participation from the students, informing them of the study's method and assuring them of identity and data confidentiality. The data gathering procedure was held in 3 different venues that involved one of the 3 processes of information retrieval. So we have one venue for the seeing, one venue for the hearing, and one venue for the reading. Now for the actual gathering or the data method that we have used, so for seeing and hearing, the learners were given a set of 15 copies of the questionnaire for the 15 different mathematical symbols that followed this procedure. 10 seconds of showing the picture or listening to the red symbol. Then after that 10 seconds, they were given 45 seconds to answer the questionnaire the questions in the questionnaire. And finally, they were given additional 10 seconds before proceeding to the next symbol. So for a total of 65 seconds per symbol and approximately 17 minutes for the whole data gathering. For the reading, we had a one-on-one testing with our learners. So the mathematical symbols were shown to the learner for 10 seconds, one at a time. And then in this duration, the researcher recorded the spoken or read symbol of the learner in a voice file before letting him or her answer the questionnaire. After 10 seconds, the shown symbol was hidden, and then the learner was given 45 minutes to answer the questionnaire. So for reading, the data gathering lasted for approximately 60 to 65 seconds per mathematical symbol for approximately 17 minutes per learner. Now let's proceed to the results of our study. So here is the table for the percentage accuracy of the image replicated from the mathematical symbols. So the 3 different modes of retrieval, which is seeing, hearing, and reading. So replicated images from the seeing procedure obtained 100% accuracy for every symbol. So this is most likely caused by the 10-second time interval to look at the flashed symbol. So they have enough time to look at the image of the symbol. On the other hand, drawn images from the hearing and reading procedure did not obtain 100% accuracy, which for hearing, we have obtained 91.75%, and for reading, we have 94.95%. Inaccuracies were especially noted for the radical sign, the relational symbols like greater than or less than, and the grouping symbols, brackets, and braces. If we look at the percentage accuracy of the symbols with respect to the categories, we obtained 100% accuracy for symbols under category B and category C. So category B are symbols with one image and multiple meanings, and category C symbols are those with multiple images but one meaning. Inaccuracies obtained for mathematical symbols under category A may be attributed to the relational symbols because our relational symbols belong to category A. Meanwhile, inaccuracies obtained for symbols under category B are probably caused by their multiple images and meanings because, as characterized by our category D, these are symbols with multiple images and multiple meanings. Since symbols under this category may be represented by several images or mean in many ways, confusions may have occurred. Now for the meaning of the mathematical symbols using the 3 different procedures, seeing, hearing, and reading. So we can see that no SHR procedure obtained 100%. So inaccuracies were consistently recorded for relational symbols and grouping symbols. We can also see a very low percentage accuracy for the radical sign. For the meaning of the mathematical symbols with respect to the 4 categories, category A and category D consistently obtained percentage accuracies of less than 100% for the 3 procedures. Despite having only one meaning, some of the participants have inaccurate meaning for category A symbols. Even though category B have multiple meanings, it still obtained 100% accuracy. We have also recorded the corresponding feeling responses for each symbol. We can see that uncertainty was felt for relational symbols and for the grouping symbols. Then positive feelings like happiness are recorded for symbols like the plus sign and the multiplication sign. And negative feelings like sadness were recorded for symbols like minus sign and the division sign. So the responses to the feelings felt were also analyzed using the ABC model of attitude. And we have classified positive, negative, and neutral aspects of every component of the model. Now for the product or for the themes, which is the product of our thematic analysis, we were able to identify 6 major themes. First one is the inaccuracy in the encoding of image and meaning of symbols with almost similar images and opposite meanings. So this is true for relational symbols greater than or less than, and as well as for symbols like equal and not equal to. So they have almost similar images, yet opposite meanings. And from there, we have recorded that inaccuracies can occur in this type of symbols. For our second theme, inaccuracy in the encoding of the image and meaning of symbols with almost similar images, regardless of the meaning. So for example, in the radical sign, it is mentioned that it obtained almost always the lowest percentage accuracy. This is because most of the students confused the radical sign for the long division symbol. Okay. And for theme number 3, inaccuracy in the encoding of the image and meaning of symbols with multiple images and multiple meanings. So this is true for category D. So consistently, category D symbols, which composed of the grouping symbols, were or obtained inaccuracies. Fourth theme is higher accuracy of retrieved encoded information for procedures with visual exposure. So this is especially true for seeing and reading. So they have visual exposure component for their encoding and retrieval information. So we have recorded higher accuracy compared to that of the hearing. For theme number 5, symbols, meanings encoded evoke aligned feelings felt upon exposure to it. So we have seen that for addition sign or the plus sign and the multiplication sign, positive feelings were also evoked, like happiness, excitement, amazement. And for minus or the division sign, we have seen that most of the feelings responses were negative feelings as well, which is sadness or confusion or boredom. For theme number 6, feelings aligned with the symbol's meaning promote higher accuracy of retrieval of encoded mathematical symbols. However, even though there is a classification of the feelings felt for each symbol, we were able to record or to observe that most of the mathematical symbols with feelings aligned to it obtained higher percentage accuracies. For the conclusion and recommendation, so our study has shown that the initial process of encoding mathematical prerequisites, such as symbol recognition, can contribute an impact on learning. So I believe this is true for all disciplines, not only for mathematics. We need to establish a strong foundation that making sure that prerequisites are learned and mastered. Second, we have inaccuracies were still recorded for both the image and meaning of the symbols, considering that the participants of the study are already in the 8th grade, and most of the symbols were already introduced in their elementary education. So this implies that as learners progress in learning, there might be 2 possibilities regarding inaccuracies. First one is that they do not have fully encoded the correct image and meaning of the symbols during the time they were introduced to them, which can be we can account to the kind of learning experience they had. Second is they might have the encoded images and meanings correctly, but some information may have been lost as they proceed to higher grade levels, which can happen according to the IPM and Ausable subsumption theory. Number 3, as we design down from our learning goals, we must not forget to build the strongest foundation to carry the weight of complexity of what is on top. So it may sound cliche, unoriginal, and simple, but our study has shown its relevance. We may not know that these loopholes exist, which we can greatly affect our alignment with our learning goals and objectives. We can also incorporate this thought whenever we conduct our needs assessment to our learners. The results of our study and the generated themes can be a baseline data for developing and improving teaching strategies and pedagogies that can address the inaccuracies identified by the first 3 themes. Results are additional evidence to the literature that procedures including visual exposure promote better encoding and retrieval of information. So this fact is, or this observation or this result that we had is especially true for concepts that are not kinesthetically possible to learn, such as the mathematical symbols. Next, further investigation can be made into the VARF model that we have created as we incorporated the feelings felt and replace that to the kinesthetic component of the VARF model. as a teaching learning style. So this is actually a good model, though not fully explored, because in our study, we were able to observe a common thing about the association of feelings in the encoding and retrieval of information. And we have the following recommendations to end our study. So we need to prioritize and improve the encoding of mathematical symbols, especially in the students' elementary education, to strengthen their basic foundations in mathematics learning. Second, we need to carefully distinguish mathematical symbols that can be a source of inaccuracy, as presented by the first three themes. Third, consider the role of affective and emotive aspects in learning mathematical symbols and treat them as part of the teaching and learning styles. And finally, administer encoding and learning procedures that invoke visual exposure, such as seeing and reading, especially if the concepts that we are trying to deliver to our learners are not kinesthetically possible to learn. And that concludes my presentation. So thank you very much for listening.
Okay, thank you, Vincent, for your excellent presentation. So have you published your work somewhere?
Currently, our manuscript is on process, and we're planning to submit it in a journal, Scopus Index, and I hope we will be able to publish it by the end of this year.
Okay, thank you. Thank you. So I think we can move to our next presentation. So I'm inviting Dr. Faisal Omar Al-Mahrouzi, and he is a teacher. He is right now a faculty member at the Islamic University of Medina in the Faculty of Engineering in Mechanical Department. And he also leads some of the administrative committees like Innovation and Creativity and Faculty Development. And formerly, he was the Dean for the development at Qasim University, building leaders and faculties to master their learning and lead in the right direction. So, Dr. Faisal Omar.
Yes, how are you?
Yeah, I'm fine, thank you. So, can you make it the presentation mode?
The slide is okay?
Slide is okay, but it will be better if you can go to the presentation mode. I think.
Yeah, it's in the presentation now.
Not the whole screen. I think F7 or something like that. Or in the bottom.
It's a full screen. I'm choosing the full screen. You see this one? This is the full screen. Okay. Is it now full or?
No, it's not the full screen. Like we can see your slides, but not in the presentation mode.
Strange. I did put it in the presentation mode now.
Just press F5, Dr. Faisal.
F5.
F5, okay. Yeah, I did, but they still do the same things.
Okay. Okay, so
It's
I
in
think
full mode
without
now.
further delay, without further delay, you can continue, please. Okay.
Do you see the slides, Will?
Yeah, we can see the slides and it's visible. Yeah, it's fine. Yeah, please continue.
Okay, first of all, how are you all? Actually, I'm trying to share with you something that we have done in the College of Engineering in the Islamic University of Medina, where we are OBD school and also accredited by ABIT. We have this senior design project, which is very famous in engineering, in mechanical engineering, where we have the outcome that we need to achieve in our project. So for our CEOs, we have something that we all write at the end of the course, to write an interim project report, develop the mathematical model, evaluate the manufacturability of the prototype. All this written in the course. But we need to achieve these things with the students. We need to have these to be reliable, and also the student apply these things, manufacturing, the prototype, perform. We have engaged in the SAE project, where we build the formula from scratch. As you know, the formula, usually formula student cars, usually involve a lot of specification, and we have to follow the SAE guidelines and also the conditions. The SAE usually part. Hello, do you hear me? Hello?
Yeah, we can hear you.
Yes. So in the SAE, we have this kind of project, which is big project. All European and American universities and all over the world, in India, in China, in Germany, in all countries, they participate in this project where the student have a very strong senior design project. We actually, the student stay 1 year, they have 2 semesters, they go through these steps of the project, they understand the specification that coming from the SAE, and they apply all the outcome of this course to achieve the mission of what we want to design and manufacture. I taught the student how we start this project from scratch, teaching them many things, many techniques. How can we have a blueprint? How can we start stuff from the beginning? We divided the formula to 5 systems. So each student assigned to some of these systems to understand it, learn it by heart, because we are designing something it's not existed. So we need to follow the guideline, and also we have a room for designing many things. Here, the student starting from the beginning, I appreciate this project because the student have a lot of insights, learning a lot of things. How can we develop this from scratch? How can we build this? And this formula, as you know, and you saw in many universities, it has a big contest in many countries. And after that, they choose a champion. So your students have to be, they have to be very strong in their background, in their knowledge, in deep understanding how to achieve these outcomes. The assessment has to be very strong. Here, the student, as you see in this one, I'm teaching the student like how we simulate this before we build the formula.
Dr. Faisal, I think your slides are not moving. Like, we can see your second slide. Are you still on your second slide, or?
No, in mine it's moving. What's going on there? Yeah, you don't see the slides at all?
No, I can see the slides, but
But it's not moving?
It's not moving. It's on the second slide still.
Strange.
Like, I can see the COs only.
Now can you see it?
Yes. Wait. Yes, now we can see. Yes.
Okay, because if I put in full mode, it looks like it's not moving. So now can you see it?
Yeah. So
Okay.
I can see the problem definition and abstract. Yes.
Yes, very good.
Okay.
So this is the formula that we want to design according to the SAE rules. And this is the SAE usually have 2 parts, static and dynamics. Your student have to be very strong in their background, in understanding the specification, in understanding what is going on with the design, applying all the knowledge of their what they have studied in their 4 years. They have to apply in this senior design project in 2 terms. They have to design, they have to manufacture, they have to build the prototype, they have to do the simulation. They have to be very strong, because the contest that we are participating in is not very easy. And we are competing with all the universities in the world, in UK, in India, in China, in Germany. So I'm teaching the student in this project, as you see in the picture, how we can build this from scratch. How can we draw the blueprint for the formula? How can we understand how we start this? Because this is a unique design. So the student have to go by innovation, by creativity. So they have to think out of the box. Usually we divide the system because every university is different. But for me, I divided the student in 5 systems. So the student can master, each one will master his system. And also they work as a team. So they collaborate, because now at the end, we will build this formula. As you can see here in this slide, here one of the students, I'm teaching him what is how this formula will be designed, and how is the driver will be inside of the compartment. Also here, we are required to have a motorcycle bike, so they are uninstalling this one. And as you can see in the picture, all this simulation, while they are in the ground we don't have anything. So they are simulating how is the size of this formula. The student have done a lot of simulation to see what is the safety factor, because this is one of the requirements. They use software, as you can see in the slide. Also, they do the aerodynamic analysis. So the beauty of this project, that they can apply everything, and they can go and see and experience everything as a team. Here the steps of manufacturing, they go through the processes after they design the concept, and they try to see how this will fit. Also, we have done analysis on the upright of the tires, different tires. They have to learn this because they don't have an experience. And also, this is our first formula that we built it in the university. They go also in manufacturing. They try many things after they have done the concept. They have done the simulation. They do the manufacturing, how this will fit. All these kind of things, it challenged the students. Here we have also they still going through the system, checking this and that. This is part of the specification and the rules that guided by the SAE. Every student have to be an expert in the specification of the SAE. Because if we violate anything, we are getting out of that contest, and also we are not achieving what we want to accomplish. Very tight design, very tight procedures, very tight in creativity. This is a tank. You need to follow what is the instructions. The student have to have a good ability to read and understand what's going on, so they can design in a better way. They can also think in different ways. We built many things for the first time. Student experience these issues. As we go along, we evaluate the processes. There is a forms, there is rubric, there is many things we follow. And there is an oral presentation at the end. And also they submit the report. And I follow with them through the 1 year, because this formula have many batches so far. Some of the systems we manufacture, if we don't have a capability in the university, we try to manufacturing according to the specification that we want, and we get some part from here and there, because the manufacturing issues has a lot of things the student have to experience. This is the prototype, as you can see. Finally, we have built the whole car or the whole formula. The students are very proud. We are very proud also that I helped the student to achieve this mission. This is a video. We do also testing, like they have done all the design, all the prototype, but we do testing. As you can see in the video here, we are trying to picture the formula, how, and we run it in the university to see how this performing, how is the performance, how is the testing, how can we achieve better quality with the testing here in this video. Is the video clear to you?
Yes, please. Yeah.
Okay. Also, there is a failure analysis. The student go through to see why this is failing, why there is a problem here and there after we do the testing on the ground, because they go through the whole phase from the beginning, from scratch, till we get a prototype, and this prototype has to function very well. Usually, we stick to the course outcome, which is we have met that this course outcome, and beyond that too, a student have gained a lot of experience and knowledge. Also, the student learning should be planned very well. Outcomes should be achieved on the floor, because many places we have outcomes, but they don't really, some of the outcomes are not achieved, because really the student have to master these talents that he gained. Professor should stress on the course outcomes along the learning, so the student will know what is the deep understanding. So not a surface understanding, no, a deep one, so they can get a lot of experience. These are the names of the different batches, and thank you very much.
Okay, thank you for Dr. Faisal for the exciting presentation, and it's really good to see that your students are working on a real life project, and it's not a prototype, it's a real thing, right?
Yes.
Okay, so I think we can move to our next presentation. So Dr. Faisal, will you please stop sharing?
Okay.
Okay, so our next presenter is Sherwin M. Alexandro, and he is an IT instructor at the Center for Preparatory Studies and Sultan Qaboos University in Muscat. So he's from Oman, and he has been in Sultan Qaboos University for last 12 years and 4 years respectively. His research interests are educational technologies, collaborative learning, and flexible learning implementation. Yeah, please, you can start your presentation.
Hi, everyone. Good morning, good afternoon, good evening to all. As early as now, we would like to thank you for coming today to join us in our presentation. We are excited to share with you our study regarding the use of the collaborative online learning, focusing on academic records management system using the Google Sheets for English courses at the Center for Preparatory Studies here at the Sultanate of Oman, specifically the Sultan Qaboos University. We would like also to thank the organizing committee for accepting our study for this prestigious virtual presentation. It is absolutely a privilege for us to participate in this global summit. The focus of this study is the design, development, and implementation of the academic records management system, and an opportunity for us to share as well our best practices in this type of area. So with my colleague, Mr. Sherwin Alejandro, will be presenting the following. So we'll be discussing the existing system that we are using for our academic records management, its purpose, the methods and results. We have also the conclusions and the recommendations later on. So to give you a quick overview of the Center for Preparatory Studies, so the CPS, or shall we say, the Center for Preparatory Studies at Sultan Qaboos University, is one of the supporting units in the university and has been designed to prepare students who have been accepted to study at the university to enable students to achieve the required educational goals. So these educational goals, the education output, are in accordance with the Omani academic standards. So the CPS has been catering to students in their English, mathematics, and IT foundation courses. So not to mention as well, English credit courses are also delivered by the Center for Preparatory Studies. Moving forward to our study, assessing student performance in class through grading is one of the most important parts of the teacher's role. The grades, as we all know, are sets of numerical data that are represented to determine the leveling of the academic performance of the students in different types of assessments. It is the process of applying standardized measurements in student learning activities through different learning components, such as the continuous assessments and examinations. Students' progress reports that would assist in identifying the problem areas of a student. It is also important information needed in advancing the students to the next level of the course. It is the most important information that is kept by the school administration, which serve as the record book of the students' performance and progress of the students as well. The academic recording is considered as one of the critical processes that must be assessed and comprehensively provide an accurate results. So the process here will add additional workload for some teachers because of its time consuming of encoding all the marks, which will take time in calculating the results other than loads in preparing their lessons, and not to mention conducting classes as well. With the advent of technology in education, educators are taking this advantage to use software to lessen or eliminate the workload in processing student performance, specifically in calculating of marks or grades. The CPS, or the Center for Preparatory Studies at the Sultan Qaboos University, recognizes the need to have good and quality ways to organize and provide accurate information for reporting to meet the university standards of requirements. One of this information are the grades of the students. One of the ways to organize the grades is through automation. That is why we came up with this EARM, or Electronic Automated Records Management System, that would record the students' performance according to the learning components of the English courses approved by the Center for Preparatory Studies. It automatically processes the students' performance following the prescribed grading system or assessment matrices set by the Sultan Qaboos University and the Center for Preparatory Studies. The spreadsheet template that we are currently using assists the users, especially the course leaders. We have from entering the raw marks up to the different learning components in the spreadsheet, then processing it to generate reports for decision-making presentation later on. It provides consistent, reliable, and accurate reports that can be used by the center and the administration themselves for any decision-making regarding the students' academic progress. About the limitations of the current system, as observed and feedback by the end users, the existing system has its own limitations and concerns. First, the accessibility is limited within the SU domain using the university account. So teachers or educators or course leaders or concerned users are able to access this one inside university. Only the course leaders and academic records officers have the privilege to enter the marks into the spreadsheet. Then course teachers are not allowed to enter marks into the spreadsheet. So with these limitations, updating the system in a more practical, reliable, and convenient way for all end users has been suggested long time ago. So that is why we need real-time updates in a spreadsheet that is highly suggested by the administration. So with all those mentioned issues, we came up with this collaborative online academic records management. So the issues raised from the previous system or existing system have been the motivation of the researchers to update the system into a more practical, convenient, and reliable one. So due to the limitations mentioned in the current system, there is really a need to update the system to utilize its use by different end users like the course leaders, the assessment unit, the administration, and other concerned teachers. To utilize the use of Google Workspace as well is the purpose of this, to support the convenience and to support the collaborative and remotely work out with the end users anytime and anywhere. Then security is one of the concerns of the previous system. That is why in this newly collaborative online academic records management, we address this to improve the access grants and restrictions that are being strengthened and to support also flexibility with security also.
So the online academic records management system in the CPS is a great book that collaboratively manages students' academic performance based on the learning components, which is we have three major components, which is the continuous assessment, the midterm examination, and the final examination, which is set by the center. So this is a practical, useful, flexible system template that can record the students' marks and handle the automated calculations of assessments marks in the center, both for foundation and the credit programs. So the grading scale in this system, management system, is based on the performance evaluated and graded using the letter grades which are employed to describe the achievement level attained in a particular course. So Google Sheet applications from the Google Workspace was utilized in designing the new system. So this modern spreadsheet software is interesting software that gives a platform for various solutions from different programs for various from different problems like the calculations and the visualization of data. So the researchers will use the rapid application development in designing and implementing the new system, which this software development methodology tool in developing the new system. So the process is to design, to evolve with changing requirements in a real time. So these are the following requirements which we need, okay, which is the requirement planning, the prototyping, the testing, and the implementation, okay, which was followed. So the students' information, course information, and the assessment scores and other relevant information will be used for the system to keep the academic records of the students. Access to the Google Sheet program has been restricted, okay, which is the most important, the security, okay, to end users depending on their role, okay, because there are many end users, okay, required for the system, okay, which includes all the teachers. Actually, in the university or in the center, we are running 43 courses. Okay, we have like around almost 300 teachers. Okay, just to consider all the 3 courses in the university, because in the university we are running 16,000 students mostly. So access to the Google Sheet program has been restricted. So the Google Sheet is shared during the, of course, the Google Drive, okay, which is accessible only using the university Gmail account. So the overall access of the system is the academic records officer, which is us, okay, to the Google Sheets and updates the spreadsheet program. So the privileges of each users are set by the ARO depending on their purpose of use. And some of the other users we have, okay, we have the course leaders, what we call the course coordinators. They are the one who leads the courses, okay, of the center. Okay, so they have the overall responsibility of the course, okay, which work closely and monitors the works or the inputs of the teachers to the spreadsheet. And the teachers are responsible for teaching and accessing students in the course. So they are the one who gathers the student marks either manually, or they have the Moodle. We are using the Moodle, so we have many activities from the Moodle, which they have to gather all the marks, okay, from the system. And mostly in our courses, in the foundation program, we are running around 1,000 of students per single course. Okay, and we have also the assessment unit who controls or responsible for providing all the assessments. Okay, the marks, okay, they are the one who updates or who give information regarding from these three major assessment, which is from CA, the midterm assessment, and the final assessment. We have also the appeal committee members who check all who check all the appeals from the students at the end of the semester, and of course the CPS management who monitors the progress of the course through reports, okay, provided by the system. Okay, so these are the results. Okay, of course, as I mentioned, the access of the system is restricted. So this is how we organize. We have the student information, which we gather from our student portal, which is done by the course leaders. They are the one who download the student list. Then they put it into the spreadsheet, which automatically deploy to the system, and automatically all the other sheet tabs will display all the information needed for the students. And then we have the course matrix, which is commenced at the beginning of the semester, which is work or done by the course leaders and the assessment unit, which corresponds to the marks for each components, which is very important. What are the marking for each subcomponents for those three major assessments? So at the beginning of the semester, actually, we design already what are the assessments, okay, from the C8 midterm and final assessment, which is approved by the assessment unit and the center management or the CPS management. So we don't need to change that one at the middle of the semester. So that's why it is designed already. So when you enter all the marks to the sheet, see, it will automatically calculate all the marks, okay, and provide the reports of the needed for the system. And this is how the teachers will enter their marks. Okay, the figure shows the entry of marks for the students' performance. So the worksheet is accessible to all the CLs, the course teachers, and the assessment unit coordinators. Now, to avoid the human errors in entering the marks into the worksheet, functions and formulas were used and implemented. So usually we orient, or the teachers are aware of how they use these formulas and functions. So some continuous assessment results can be mostly taken from the Moodle activities, and the objective or the results of the midterm and examination usually are taken from the assessment unit, because we are using online examinations. We are doing examinations using the OMR sheets, which is done by the machine, and we just collect them and then they put it into the raw mark sheet. And writing marks, okay, for English courses on the other hand, are collected from the marking using a separate spreadsheet. Okay, so usually this is not designed and not connected to the spreadsheet, and that is one of the recommendations. And the remarks column is used usually for feedbacking, which is used for appeal committees, okay, with regards to changing of grades. And of course, the data validation has been set to avoid the invalid entry of marks. Okay, so if they are entering more than the number of marks needed, or maybe less than 0, okay, it's not allowed. So if a marks entry is invalid, the system displays an error message and will not accept any entry or 0 if entered. So self-formatting is used, or some of the functions or preferences was made just to avoid these things. And these are the actual results of the system. This is restricted to everyone except for the academic records officers. Okay, so this is not even, this is also restricted even the management, even the teachers and the course leaders. Okay, why? Because this sheet basically the results of the students and nobody can change it. So the weighted mark sheet shows the progress result of every student in the course by the actual marks. So the calculated marks will be shown in the worksheet by automatically calculating the score to their corresponding marks. Okay, so which includes the percentage marks and the grade equivalent. And also the averages, okay, which usually to understand the results per components, okay, which is used by the management with regards to comparing the results for the components, okay, from 3 major assessments for any other actions in the next semester, okay, and of course the comparison of the section of averages, okay, which includes, as you can see from your screen. So we also find the median, okay, the range, okay, the deviation, okay, the percentage for each components, which usually they do a presentation at the end of the semester. Okay, so this is ready for use for any decision making. And of course, lastly, the reports, the statistics and averages sheet tab shows the comparative statistics, okay, between the semesters and also, yes, between the semesters, okay, which usually these comparative statistics for each letter's grade and averages show the graphical comparison. Okay, so this will help the administrators to oversee if there is an inflation of the grades and marks among the semesters. And also, one of the actions made by the teachers and the course leaders at the end of the semester, we need to upload our marks to the portal. Okay, we have the student portal so that the student may see their marks, okay, online. So this one shows the generated Excel file. Okay, for uploading the students, okay, we have to convert this one into a CSV file, and the teacher will upload their marks to the system. So the file will be uploaded by CL or any other course leaders. And of course, the summary of the reports, okay, for the CPS administration, which is based as a basis for the next semester. Okay, so how many fails, how many pass, how many got A's. Okay, so this report generated can be used for any decision making done by the CPS administration. Okay, generation of the students' final marks. Okay, for SKU portal sheet will be used for references for appeal cases and summary reports, and the overall statistics which also we use or submit this one to the university registration. Okay, and these are some of the results. And we do this one every semester because we do some presentations every end of the semester. So we have all the statistics even, okay, per course, per majors, okay, because how many colleges do we have in the university?
Okay, thank you, Sherwin. So with all the mentioned background, process, purpose, therefore we conclude that organizing the students' academic records is one of the important means of supporting the overall teaching and learning process in the CPS or at the Center for Preparatory Studies. So the online academic records management or the online ARM system is one of the important assets in the CPS because it demonstrates the recording and processing of teaching and learning components in one, of course, as part of the academic records of the students. So these components basically compose of many course learning outcomes that the students will be tested from. Then it gives emphasis on the importance of grade integrity, availability and confidentiality, the use of assessment matrices, grade scaling, and the statistics and averages of the different components in one course. This will also allow the different users and audience to understand the practices of the CPS on how it keeps, processes, and secures the academic records of the students to be used for presentation to the stakeholders for academic planning and decision-making. The new and updated online academic records management system, which is collaborative in nature, was implemented successfully at the CPS in some selected English courses in spring 2022 and used by the identified end users like the teachers, CLs, the assessment unit, and the CPS administration. It has allowed these teachers to remotely work and collaborate with different end users as well. It followed the standards set by the SQU and CPS in assessing the different outcomes and progress of the students. With the help of information technology, the generating of students' performance can be done both fast and easy. So in Google Workspace applications, users can work definitely collaboratively in a stable environment. The Google Sheet application is one of this as one of the powerful tools used in developing the online academic records management system, which supports collaboration, convenience, security, and flexibility. So to end our presentation with these recommendations, several recommendations from the end users after the first implementation were presented to improve systems functionalities. And the following are the recommendations. First, documenting the user acceptance testing should be done at the end of the semester to identify the weak points of the system. In addition, with the limitation of accessing the system with its SQ domain, collaborative electronic records management system is highly recommended for easy access by the end users, not just for English, but for all courses in the CPS at SQU. There should be an orientation by the end users use every beginning of the semester. This is to familiarize themselves and walk through the features of the system. And lastly, there should be an end of semester feedback from the end users regarding their experience and usefulness. And that would be all. Thank you very much. And thank you for listening.
Okay, thank you. It looks like you have developed a very comprehensive system, right? So how is the feedback from the course teachers?
Usually we as of now, we only gathered the feedback from the course leaders, because this is the first time that the teachers are using the system, because they can work. Because recently the existing system that we use was they are not allowed to enter to the system because of the difficulty of the security in entering the marks. So hopefully we can gather the feedback now from the teachers for this semester.
Okay, so if I understand correctly, like you used some of the facilities of Google Workspace, right?
Yeah, because the university are using Google Workspace since the pandemic. So since the pandemic, we actually use this one. That's why we introduce also the use of the Google Sheet for this purpose.
Okay, so
and more convenient for our teachers.
So that means if they provide input in one Google Sheet, then those values will be automatically feed into your system.
Yes. That's the very purpose of having this new system implemented.
Okay, because some of the universities, like, they developed based on Excel, so but then they have to write everything, the like how they connect the Excel sheets with the system. So here it will be connected to the Google Workspace and the Google Sheets, right?
Yes,
Yeah. Actually, the problem in the spreadsheet is as we mentioned, we only access the system inside the university because we have the SQU domain. But since the Google Workspace, you can accessible everywhere, anywhere. So even the teachers are in their homes, so they can access the system now.
Okay. Thank you for your presentation. So if I understand correctly, it was the joint presentation, right? From because in our list, it's showing that there are two presenters, Sherwin and Alexander, but you are presenting one presentation jointly, right?
Yeah.
Okay. Thank you for the clarification. So we are moving to the last presentations, and I'm inviting Professor Dr. Nazmun Nahar, and he is a fellow of IEB, and he joined the Department of Civil and Environmental Engineering at North-South University in fall 2013. And after graduating from Bangladesh University of Engineering and Technology, Dr. Nahar joined Purdue University and earned her PhD in Civil and Environmental Engineering. Dr. Nahar is a registered professional engineer, that is PEng, in the province of British Columbia, Canada. She has over 20 years of experience in research, teaching, and consulting in North America and Bangladesh as well. So, Professor Nahar, yeah, you can share your slides.
Hello, everyone. This is Dr. Nazmun Nahar from North-South University, Bangladesh. The title of my presentation is Assessment of Learning Outcomes for Engineering and Technology-Based Curriculum. And I would like to thank my former colleague, Dr. Arshad Chaudhry, for his kind permission to use some of the material that I'm going to use in this presentation. So, as we'll be talking about curriculum and assessment process, so I think it is. I'm hoping that the participants would be able to, define curriculum after this presentation, curriculum and other relevant terms, describe the different types of assessment method, and develop an assessment protocol at the course level and at the program level. So this is the presentation outline. So we'll be talking about why assessment, different types of assessment, selection of assessment tool and assessment criteria, CO assessment, PO assessment, and then closing the loop. I wouldn't go as one to mention about the curriculum. It is misunderstood. So curriculum is a design plan or a roadmap that is designed to sequentially improve the student's knowledge, skill, and attitude with prescribed set of courses, lessons, and activities that the students have to complete to get the required degree. And according to ABET, the program curriculum must provide adequate content, and it must be consistent with program educational objectives and program or student learning outcomes. Dr. Nagaraj already mentioned about program educational objectives and the program outcomes. So the reason for doing this, for a reason for this consistency, is because we want to make sure that students are ready for the workforce. However, I have a little bit of thought here that we need to keep in mind that we are preparing our engineering professionals for life, not only for a livelihood. And we would like to equip them with knowledge, at the same time, moral values, social and environmental consciousness, and some sort of spiritual insight. And by spiritual insight, I'd like to refer to higher calling and giving back to the community, this type of concept. And this idea I got from the concept of whole person education concept, which actually connects the academics to values. So this is a typical engineering-based curriculum where you see, so I was talking about a typical engineering curriculum. So this is the format of an engineering curriculum that includes the vision and mission of the program, vision and mission of the university, and also vision and mission of the program, the degree giving program, whether it's a Bachelor of Science in Civil Engineering or Masters of Science in Civil Engineering. It must include the program educational objectives, POs, COs, teaching and assessment strategies, etc. So this is the typical curriculum format. These are the terminologies. I'm not going to go over this. Now, the question is, why do we need assessment? We need assessment because assessment assures our stakeholders that students are attaining the required knowledge and skill and attitude. And it also indicates the preparedness of the students for the job market or for the workforce. It tells the students whether they are comprehending the material they are given. It also tells the teachers whether their intended learning outcomes are being achieved or not. So the constituencies for the assessment is they are the students, our faculty members, our alumni, our industry partners, or the employers, right? So we do assessment at course level. We also do assessment at program level. And there are different methods of assessment, as I mentioned earlier. So there is the direct versus indirect method, formative assessment method, summative assessment method. We have rubrics method, holistic rubrics versus analytical rubrics. So while doing the assessment, we get feedback from the different constituencies. So students' feedback we get either from their end of semester course evaluation survey, then we get the exit survey for graduating students. We have personal level student interaction. We also get faculty feedback from the different department meetings or faculty survey at the end of the semester. We get industry input or feedback from industrial advisory board meetings or our employer survey. We get alumni feedback similarly from our graduating student exit survey or our alumni members survey. Generally, we get this feedback that helps us to make an understanding how the learning is going on and how the learning happened in the past. So if I very quickly, if I can talk about the different types of assessment methods. So direct versus indirect method. Direct method is the method where it's the direct examination of the faculty member of the student's performance. And typically the different tests, quizzes, exams, these fall under the direct method. The indirect method basically it deals with the perception of student learning, okay, or the learning experience. So it's more about employer survey or from the exit survey. It's more qualitative in nature how the learning is happening. The formative assessment and summative assessment is another type of assessment methods. Formative assessment is basically we do it's an ongoing assessment method that we monitor the student progress. So students know how they're doing in a continuous basis, or as the faculty member, they recognize that where the students are struggling and where to put more emphasis, those kind of stuff. So formative is a continuous process, and we can talk about in-class discussion, or maybe 1-minute question, or a group discussion in the class. Those kind of stuff we consider as part of the formative assessment, or very quick assessment in the class. Like if I say at the beginning of the class that, okay, we're going to have a 10-minute small it's like a test at the end of this class. So I just want to see how you are following the class. That is a part of a formative assessment. Whereas summative assessment is more like we do at the end of any particular instructional unit. So for example, if I say that, well, after we are done with chapter 1, there will be an assessment for you. Or maybe after completion of a particular topic, we'd like to have a test to check how they comprehended the topic. So that is more summative in nature. And again, quizzes or MCQs, any writing of essays, take-home exams, etc., can fall under that category. On the other hand, rubrics is more detailed and very specific. It has very detailed, performance criteria elaborated in the rubrics method, and they have 3 components. It has the dimension, the scale, and descriptors. So, for example, the KPI that we say, the key performance indicators, this is dimension under rubrics, and the scale is like different level of performance, say satisfactory, unsatisfactory. This is what we call scale, and any detailed description in the middle, these are called descriptors. So there are 2 different types of rubric method: holistic and analytic. Holistic is the overall expression or impression, and analytic method when we focus on some important dimension of the student performance. I wouldn't go into the rubrics method that much in today's presentation, but this is just an example. So you see that this is the rubric for program outcome, which is teamwork, which is one of the program outcomes by EBET, one of the 12